Hi, and welcome to this lecture on wind and currents. If in the last lecture we talked about convection and the way it works, here we're going to be looking at two examples of convection in both the atmosphere and in the oceans. So, air has the similar property to other things, that it goes from areas of high pressure to areas of low pressure, and that movement of air is basically wind. Most things do this. You can think of, say, blowing up a balloon. The air inside that balloon, because of the kind of the pressure put on it by the rubber or whatever the balloon is made of, it kind of puts it under pressure. So the air is trying to get out of the balloon. That's why when you let go of the end of a balloon, the air all comes out. It's going from high pressure inside to low pressure outside. You can think about if you've finish off a Coke bottle and kind of suck the air out of the Coke bottle, it tries to suck your tongue back into the bottle. So that's a low pressure zone, kind of trying to pull things into it. So all in all, things go from high pressure to low pressure. With air, it usually gets hot at the equator because of it's getting more direct sunlight and for longer periods of time, and it warms up. When it warms up, if you remember, it becomes less dense because it has to spread out, and so since it's less dense, it rises. It moves up like this, up into the atmosphere, and leaving behind an area that air has gone out of, thus making it a low pressure area. And on the other side of things, you have cool air, which, as you remember, it becomes cooler. That allows the molecules to get closer together. It becomes more dense, and so the air sinks. Here in this example, we've got the cloud blocking the sun's rays, thus making all this air cold. It gets dense, and then it falls down closer to the Earth because it's dense. And so what you start to get is like almost a conveyor belt of this cold air, which is in a high pressure zone, being kind of sucked into a low pressure zone. Like if this was a balloon, the air would be flying out of it to the outer area, to the air around it. We can look at the way that air does this globally speaking. Here's a kind of slightly blurry example of the Earth. And you can see that there are kind of ongoing patterns of airflow around the globe. For instance, let's say if this is our equator, the equator gets a lot of sun, so the air there becomes very hot. It expands, it rises up into the atmosphere. Once it gets into the atmosphere, it cools. Once it cools enough, it becomes dense, and it sinks down back towards the surface of the Earth. It's pulled, once again into this area of low pressure, and so on. It's like an ongoing cycle, and these kind of conveyor belts occur, broadly speaking, throughout the Earth in three kind of distinct bands of the conveyor belt, three to the north and three to the south of the equator. You don't need to worry about what these are called, but this is what shapes global wind patterns. On the other hand, air also does this locally in ways that can go against like the prevailing wind pattern of a general area. For instance, on this little graphic here, you have the air over the sea being pretty cool and being dense and rushing into the low pressure zone created when air over land got hot, expanded, and rose up. You can imagine that once this air rises, it'll eventually start to cool down, and eventually sink down. So in this kind of small area as well, you'll have a conveyor belt system. And that's something important to keep in mind when we talk about different weather patterns in future lectures. The air is always kind of interacting with different airs of different temperatures, airs of different densities, and reacting to pressure and moving accordingly. Currents are basically the what happens when you have convection in the ocean. Now, a current is just another name for any kind of water flowing in a particular direction. In the ocean, the currents have the side product of distributing heat throughout the globe so that it doesn't get too hot at the equator or too cold at the poles. You generally have warm water that water near the equator, which once again becomes warm, flowing away from the equator towards the poles. And as that water gets towards the poles, it gives off heat into the atmosphere. So the water loses its own heat. It gets a little colder. It also, some of it evaporates along the way, which makes it saltier and denser. So the coldness and the extra salinity, the saltiness of the water, does make it dense. And once it gets dense, as you can see, it starts to sink down towards the bottom of the ocean. Once there, it kind of moves along the bottom of the ocean, once again kind of pushed away by this high pressure area here, and moving towards this area of low pressure where water had been warmed and then kind of rose up and towards the poles. And so the ocean has its own little conveyor belts level. They look kind of like this, and this is a real simplification of things. But you have this warm air. All these warm currents near the surface of the oceans. It got warm because it's kind of in the mid latitudes, in the low latitudes around the equator. And here in the Atlantic, it streams up, and this is a simplification. In reality, it goes like this as well. This current of warm air, of warm water, heated by the sunlight that hits the equator, comes up through the Atlantic, and it warms us up a lot. South Carolina is kept extra warm because of this hot current that passes right by us. It's called the Gulf Stream, which you've probably heard of, and it goes here. It goes over to Europe, and it warms up Europe too. Like, you think about, say, Paris, the city of lights and city of love. It is about right there, and it's a nice warm place. But if you look at other cities on its latitude, it's it's up in Canada, but Paris is way warmer in general. Has a much nicer climate than, say, this part of interior Canada, and a lot of that is due to the fact that the nice warm Gulf Stream heats it up as well. Same with, say, let's take the United Kingdom, which is on kind of a par with northern Canada over here, but the United Kingdom has much nicer climate. Once the Gulf Stream gets up to here, it's given off a lot of its heat, and so it's become dense. It sinks towards the bottom of the ocean, or at least to a greater depth than the water above it, and heads back, fleeing this area of high density to areas of low density. And it actually goes underneath the Gulf Stream, so it's kind of weird. You have the current on the surface of the ocean heading north, while just underneath it you have a cold current heading south. So the ocean is a complex place, and I think that's where we'll stop today. So learn this stuff, and I'll see you in class.